I'm Jackie Garofano, Chief Technology Officer at CCAT, the Connecticut Center for Advanced Technology. We've created a series of videos on how to use model-based definition. Now, Nasir Manin, Principal Engineer at CCAT, is partnering with technology providers out there in the ecosystem to show you how to incorporate their software into your workflows.
Today, we're going to be walking you through the use of Mastercam for CNC programming. And more specifically, we're going to look at how model-based definition can help streamline that process. I have here with me today Dave Matuzek of Trimec, who's going to walk us through.
Thanks, Nasir, for having me here today. As Nasir mentioned, I'm Dave Matuzek from Trimec, and I'm a solutions consultant. And I'm going to talk about where Mastercam fits into your manufacturing process, because CAD is a great tool to take what's in your mind and make it a concrete idea, but this part needs to be manufactured. So you need a way to get this part into that machine so you can have a completed part come off of it. And that's where I'm going to talk about Mastercam. We'll talk a little bit about MBD. And if you have any questions as I go through it, just feel free to ask.
Great, thank you. Yeah.
All right. So I have a real great example here. Kind of a simple part, but we have some model-based definitions on it already. So I have some features identified, such as these holes. And I have another hole called out, and I have some tolerances here, so I know what numbers I have to work with. And in the past, I'd have to have this all in a blueprint in front of me. I would bring in the solid model, and then I would have the blueprint.
Yep.
Well, let's make our world paperless and have this data with the model so it can't get lost.
Great.
So I'm here in Mastercam, and I'm going to open up that file. Now, one of the great things about Mastercam is I can actually import from many, many different types of CAD and CAM software. But for this case, I want to bring in a step file. So I'm just going to switch this here to step files. And I'll grab the step file I want to bring in and open it up. And you can see that it brought in that step file with all that model-based definition already defined on it. And now I can work with this file. And again, one of the great advantages is I don't have a piece of paper following this model around.
Yep.
It can't get lost. I can't have the wrong blueprint. I've seen that happen many, many times where someone has the wrong rev of a print. So it's all tied in here together.
Yeah, one of the great things that I noticed here right away is that the confusion is eliminated. There are instances where I've had many experiences. I don't know where or what surface a particular measurement is actually calling out on. So it's great to see this in 3D, and it completely eliminates that confusion.
Correct. I can tell where my datum surfaces are, where I may want to have the stop and the vise for the machine for a datum, and where to do all my measurements from that MBD data.
Great.
Which helps me in machining this. For example, this distance here, this 2 inches, I can't really make it much smaller, but I have a lot of leeway if I want to make that a little bit wider for some reason. But I really don't have that much leeway on that dimension, the 3.375. Maybe there's a mating part in here. I don't necessarily know as a programmer or machinist what that difference could be.
Right.
But at least I have that data here in front of me. Pretty open on the holes. Plus minus 10 tells me I don't need to ream this hole or mill it. I can put an insert drill through the middle. And these are just clearance holes. I can tell just by the tolerances and the numbers it gives me. Okay, let me just set up and do some toolpaths on this. And then we'll post out some G-code. Okay. And then you'd be able to load it into a machine.
Great.
So the first thing I want to do is I want to define where I'm going to put my plane and my data. Very easy for me to do in Mastercam. I'm just going to drag this gnomon over here. And I'm going to put it on the intersection of these two lines. And I want my z-axis pointing straight up in the air. My x is good, y is good. And I'm going to give it a name. I know I can name that whatever I want to name that.
Okay.
And there we go. And let's just double check our plane. See, it's in my plane manager, its name. It actually brings in the annotation views from my MBD data. So if I wanted to make sure that I had the correct datum, the correct plane, I can actually double check in here. So that can be a very handy reference tool for you later on.
That's great. It reads it right in from the SOLIDWORKS file.
Correct, yep. And let me load a machine in. Basically, I would pick a machine that matches what I'm doing here. In this case, I'm going to pretend that we're going to put this in a 3-axis machine, so I'm just going to use the default post-processor, and I can do some basic setup now. There we go, hit the correct button there, and let's get started here. So I'm going to rough out this area here. I'm just going to focus here on this part here. So I'm going to go to drill, not drill, dynamic, we'll drill it later. And I'm going to avoid. Now, another real interesting feature about Mastercam and its toolpaths is I have ability to do standard regular cutting, as you might be familiar with. You set your speed and your feed. And I also have tools like radial chip thinning, which allow Mastercam to base its speeds and feeds off the chip load of the tool.
Oh, wow. Okay.
So I'm going to use that right here. And yes, I am making up numbers here. We're machining unobtainium, I like to joke.
Sure. Yeah.
So I'm just going to set some numbers. And it will set the speeds and feeds based on the chip load. So I'll just come in here, and if I change my step over distance, my feed rate's one thing. If I make my step over a little bit bigger, which would increase my chip load, my speeds and feeds will adjust accordingly. So I'm always maintaining the same load on the tool.
Oh, wow.
And that greatly increases your cutter life.
Yeah.
The next thing I'm going to do here, if I wanted to do a more complex simulation, I can actually pick a holder also. So we'll just pick a holder and set my tool projection to be a number that makes sense. I can see taking a 3/8 end mill and easily sticking it out an inch.
Sure. Yeah.
And I'm only going to leave 10 thou on my walls for a finished pass, and it'll bring the floors right into size. And I'm just going to tell it to cut that deep and pull that number right off the model.
Okay, great. Yeah.
So here we go. We now have this part toolpath.
Yeah, that's a really great feature to have maintain a constant chip load on the tool. That gets rid of any of the manual calculations that somebody might do in order to get there.
And now what we can do is let's use some of our MBD data to maybe machine these, use different strategies on the different walls. For example, this wall here is wide open. You know, obviously one strategy is I could cut it all in one path.
Sure. Yeah.
And I think what we'll do here is we'll cut to here. And I'll put some cutter comp on. And using your stock to leave on walls, I get +5, -1. Maybe I can also get this a negative number. So I don't mind if it cuts a little more into the wall than if it cuts a little bit fat. So I get a couple thousandths to play with there. Maybe I'll say, you know what, it's okay for you to cut -2 thousandths on that wall.
Okay, I see. So you're kind of going to the mean of the
Going to the mean of the dimension there. Correct. And I'll just make my lead-ins and lead-outs a little bit smaller. And we have a cut right there.
Yeah, I see the benefit of having that measurement and the tolerance range right on the model. You can make that decision without having to leave this 3D workspace.
Correct. I don't have to leave my workspace. I don't have to look at a blueprint. I don't have to call up engineering and say, hey, what's the tolerance on that feature I'm cutting? So that saves me a lot of time. And a lot of fatigue. It can be very fatiguing through the day. You're being paid to think, and having to go between all those features slows you down.
Absolutely. Yeah.
So this is really the basics of MBD. I can use this data on my screen in order to cut parts, see tolerances, see datums. For example, if I needed to, if there was a datum surface where this had to be parallel and flat to the bottom surface, I can make sure that's already done before I start milling it. Maybe it has to be ground or what have you. Or if there's a datum from the bottom here to the top of that surface, I know that's where I need to measure, and that's what I really need to worry about. And let me show you another neat thing that I can do using some model-based definitions.
Sure.
A real common thing that you might run into, I have a SolidWorks part here. This plate has a lot of holes in it.
Mm-hmm.
And one common problem you might run into, for those of you who don't know, the drill size for a 3/8/16 tap is 5/16 of an inch.
Mm-hmm.
Well, this part has, and I'm not going to tell you which ones are which, all the holes in that plate are either 5/16 holes or 3/8/16 tapped holes.
Okay.
Most CAD systems model the drill diameter for a tap and then has a call out on it.
Yep.
SolidWorks is no exception, but I have a really neat feature I can use in Mastercam in order to get over that hump. Otherwise, I have to have a blueprint in front of me telling me which hole is which. And I believe there's 150 holes that are half and half.
That would take a lot of time.
That would take a lot of time, and it's very easy to select the wrong hole.
Yep. Yep.
So let's do this here. I'm going to go to I'm just going to load my machine in again. And I'm going to put some stock on it so we can see it verify. And I'm going to use my feature-based drilling. Now, by default, here's what I'm going to talk about. I'm going to let it run through the hole detection.
Mm-hmm.
And it found every hole in the plate, and each hole in here listed is 5/16 hole. Some of them have chamfers, some of them don't.
Mm-hmm.
Well, I'm going to read the data directly from that SolidWorks model.
Oh, wow. Yeah.
So I'm going to come in here, go to that plate, and it's going to talk to SolidWorks now. So Mastercam's talking to SolidWorks. They do have to be on the same computer.
Okay.
But what's going to happen here in a moment is it found all the features.
Wow, 472 features.
And it knows which ones are tapped.
Yep.
Let's turn on select common features here. So if I click here, here are all the tapped holes. It found them all automatically. Here are all the drilled holes. Found them all automatically. So it found all the hole wizard data directly out of SolidWorks.
That's amazing. That's a huge time savers right there. I mean, just the amount
very
of
much
holes,
so.
over 400 holes that identified within a few seconds.
Mm-hmm.
That's amazing.
And then it's just a matter of me hitting OK and letting Mastercam generate the drilling toolpath.
Wow. I mean, this really speaks to the power of model-based definition and being able to get in the information that you normally would manually put in from a 2D drawing. I'd be sitting there and essentially programming each of these holes. Probably would make some mistakes. I'd have some iterations as I go through my simulation to see where the mistakes ended up being. And yeah, this is a huge time saver.
And it's a huge time saver for you, for quality control, and the customer.
Yeah.
Because let's say you had a plate with 400 holes in it.
Yeah.
It's one thing to forget to tap a hole.
Yep.
It's another thing to tap a hole you didn't mean to tap.
Right.
It's always easier to take more material off.
Yep.
So you could destroy a whole day's production accidentally by misreading a print or miscounting the number of holes.
Yep.
In this case, we're lucky these holes were in a pattern.
Yep.
But what if they weren't?
Right. Right.
Mastercam also has some great functionality outside of milling. Have you ever done any mill turn work or multi-axis machining?
Multi-axis.
Did you know Mastercam has several different levels of multi-axis machining available to you?
No.
Well, I like to tell people right off the bat, everybody has 3+2 machining.
Mm-hmm.
Let me show you what I mean by that. Let's say we have a part similar to this. This part actually has a little bit of everything on it. Mm-hmm. But you have the ability to do basic 3+2 machining right from standard 2D toolpaths. All I'm doing here is machining this in one axis to rough it out. And I'm creating planes, just 2D planes, to do the other faces.
Oh, okay.
So for example, let's say I want to machine this face. That's the only one I haven't done yet. Again, just like you saw before, I'm going to drag this gnomon up here, just tell it where my origin is, make that my tool plane and my construction plane, and I can do a toolpath right on that face without the need to purchase additional software. So 3+2 machining, indexing as I call it,
Yeah.
horizontal machines, is all built right in the most basic levels of Mastercam.
Oh, wow. Yeah. That's
The-
very powerful.
And you know what, I could do all these faces, and I did here just for demonstration purposes. I could machine all these holes that exact same way. Make the plane, drill the hole.
I see.
Index, make the plane, drill the hole.
Mhm.
Mastercam gives you yet another option, and that is the curve and drill 5-axis add-on. It's all built in the same drilling toolpath, so there's no
Okay.
need to learn a new toolpath.
Okay.
I can just come in here, I'll go to drill. If I pick, say, this hole here,
Yep.
this hole here,
Mhm.
and let's get real fancy, let's just index way over here, and that hole there, and under my tool axis control, if you have this add-on,
Yeah.
you'll have options here beyond 3-axis. So
Oh,
I'll go to
okay.
here to 5-axis.
Yeah.
In my tool, I might not have all my tool height set correctly. My tool is going to index. Oh, I did something very wrong here. Let's go ahead and fix that. Not a big deal. I misclicked. I have an arrow. These have to point towards my axes, but it's very visual.
Yeah. Yep.
So if something like that happens, you never have to panic in Mastercam.
Yep.
You can just go back in and say, man, I had an axis going the wrong way. We'll click on it. We'll change it.
Yep.
That looks better. I know I don't have the correct enough reach track there. Again, it showed me that right off the bat. We don't want that to happen, but it's visual. Again, Mastercam,
Yep.
everything it does is visual, and I can come in here and just know that, hey, I really need to give it a bigger clearance height. Now I know I can clear that part before I index around.
Wow. In a matter of a few clicks, you've got 5-axis program.
Correct.
That's amazing.
And then if you want to, from there, you can get into full simultaneous 5-axis machining. A good example might be right here where I wanted to cut a feature. And rather than surface machining,
Oh, yeah. I see. Yeah.
and I can go so far as simulating it.
Wow.
So this is, now this machine can be customized to match your machine.
Sure.
So
Yeah.
if you had the vari-axis, you'd bring in the vari-axis. This is just a generic machine they give you.
I see.
And do you do any turning here in this year?
We do.
Do you want to see some cool turning
Yeah.
features here in Mastercam?
Sure. That'd be great.
I am able to simulate things such as a steady rest. So I'm using my steady rest to face, put a tailstock in there, retract my steady rest, and now I can simulate my turning, which is stock aware. My stock is that shape, it's
Oh, I see.
casting.
Yeah.
So Mastercam knows where the stock is.
Okay.
Plunge grooving. Dynamic turning, which is
Oh,
a
wow.
technology
Yeah.
that is very similar to dynamic milling.
Mhm.
Here I'm actually simulating, so I just did some plunge turning in this case to show you yet another technology.
Sure.
Is there anything else you want to see, or?
You know, one of the things that is interesting is maybe going from a 2D PDF
Yeah,
and
let
doing
me.
some kind of a laser cutting operation.
Yeah, let me show you that. That's
Sure.
actually great. This is actually new in Mastercam. For many years, people have been asking us, can you bring in a PDF file?
Mhm.
And the answer before was convoluted. Mastercam very recently gave the ability to import a 2D PDF file. It has to be a vectorized PDF, so it's a PDF that's
Okay.
consisting of lines or
Sure.
arcs and some splines.
Sure. Yep.
And I could bring in that vector because a vector is a line,
Yep.
an arc is an arc.
Yep.
So I brought in this part here. It's for a personal project of mine.
Yeah.
And now come in directly and run toolpaths on this. If I was going to run a laser on this, I would have to obviously have a laser post, but I could come in here and just do my toolpath.
Yeah.
Or if I decided I wanted to mill it on a router, I just did my toolpath right there, right off of that PDF file.
Wow. That's powerful. Yep. Yeah. Yeah. Another time saver here in using Mastercam to do the toolpathing.
I'll give you a real-world example of where this has been a great way for, usually the CAD system talks directly to Mastercam.
Yeah.
I actually used this recently to bring in some PDF files, save them as DXF files, and brought them into a CAD system.
Okay.
So that way the CAD system could have the data from the PDF.
Oh, well, yeah.
And then from there, they had full parametrics, full solid modeling capabilities.
Yep.
We were able to make a solid model, and then we brought that right back into Mastercam.
Oh, nice.
So we used it as a translator.
Oh, great. Yeah, yeah. Thank you, Dave, for walking us through Mastercam and showing us all the capabilities that are there within the software, particularly using model-based definition to help save all that time. It's amazing how just with a few button clicks, you can get an NC program and get it over to your machine. So you're not focusing so much on the manual work of going back and forth between a 2D print and then putting that information or using that information to make decisions in your toolpathing, but instead you're just reading the information that's there right on your screen. It's right in front of you. There's no confusion. This is an excellent way to maintain a thought process and go through your whole programming without having to leave the software. So thank you again for joining us today. I hope that you see the benefit of model-based definition and what it can really do for your company. You save a lot of time. It really helps with optimizing processes, and at the end, it really helps to drive efficiencies in your business.
It's important for your company to become an early adopter of using model-based definition. The reason for this is because the Department of Defense is already flowing down requirements into the industrial base to do so. Wherever you are, there are a lot of resources out there to help companies start their MBD journey. If you're not sure where to look, we're CCAT, and we're here to help.